Hello friends, in today's question, a solid horizontal surface is covered with a thin layer of oil. A rectangular block of mass 0.4 kg, sorry it should be 0.4 kg, is at rest on this surface. An impulse of 1 Newton is applied to the block at time t is equal to 0 so that it starts moving along the x-axis with the velocity v, which is governed by this equation, vt is equal to v naught e raised power minus t upon tau, where v naught is a constant and tau is 4 seconds. The displacement of the block in meters at t is equal to tau is, we have to find out. So it means, first of all, we have to find out the displacement of the block at t is equal to tau, and tau is given as 4 seconds. So it means we have to find out the displacement at t is equal to 4 seconds. And it is given that this is our x direction and we have a block lying here which is 0.4 kg and impulse of 1 Newton second is applied to it so that it moves with the velocity v along x-axis. Okay. So its displacement will be also along x-axis. Now it is given that an impulse is applied. So we know that impulse is nothing but change of the momentum. We can say impulse is given as, let us suppose denoted as I, is equal to delta of p, and from here we can also say that I is equal to delta of p is equal to m change of the velocity. Okay. Now we can find out the value of the delta v. We can say that our delta v is nothing but velocity at t is equal to 0 minus initial velocity. This will be our delta v. But the initial velocity is 0. Okay. So we can say but initial velocity is equal to 0, therefore delta v is equal to velocity at t is equal to 0, and it is given that the velocity at t is equal to 0 is given as v and governed by this equation. So this will, we are going to get this as v naught e, and this will be minus t upon tau at t is equal to 0. So we substitute value of 0 in this equation, we get delta v rather will be equal to v naught. Therefore the impulse I, from here we can say, therefore impulse I is equal to m multiplied by v naught, because delta v is equal to v naught. So if substituting the equation this, we get I is equal to v naught, and impulse is given as 1. So from here we can say our v naught is equal to 1 upon m, mass is given as 0.4 kg. Therefore, we can say our v naught is equal to 5 upon 2 meter per second. And we already know that the velocity, we can say for x is the displacement, then v, velocity v, is equal to dx upon dt, and velocity v is also given as v naught e raised power minus t upon tau. And we already said that the value of tau is 4 seconds, that is, okay. We can say we're putting value of tau as 4 seconds and value of v naught as 5/2, so we get this as 5/2 e raised power minus t upon 4. Now we can just manipulate this equation. We get dx is equal to 5/2 e raised power minus t upon 4 dt. Now it is left only to integrate it. So we integrate it 0 to x, dx is equal to 5/2 integration from 0 to 4 e raised power minus t upon 4 dt. Now this will be coming equal to as 5/2, so e raised power minus t by 4 divided by minus t by 4 within limits of 0 to 4. And our left side will be only x, which is equal to minus 1/4, sorry. Excuse me, please. So we get this as 5/2 multiplied by minus of 4. We substitute the value, we get e raised power minus 4/4 minus e raised power 0. So we get this as minus of 10, e raised power minus 1 and minus 1. And it is given that the value of e raised power minus 1 is 0.37. So we can say therefore x is equal to minus 10 is 0.37 minus 1, which will be equal to minus 10 into 0.63 with minus sign. Therefore we multiply it, solve it, we get x is equal to 6.3 meters. So this is the displacement of the block when impulse of 1 Newton second is applied to it. So this completes the question. Thank you.